Now let's continue with the second topic, lecture 2. Okay. Now, as you see the content of lecture 2, right? The content of lecture 2 is creating a subroutine. In exam, I will usually ask you to create a subroutine. Okay, your test, you create your own subroutine. Subroutine is very important, right? You can reuse. You want to do something, you can reuse that particular code for anything. So that's the purpose of subroutine. For subroutine, there are actually 3 types. Actually 2 types only, procedure and function. Okay, this is a simplified version of a function called lambda, especially designed for Python. Okay, so subroutine only 2 types. One is procedure, the other one is function. So for procedure, there is no output. There is no return function, return statement. Later we will see. For function, there will be an output. For procedure, for example, you want to print out an answer. You just want to print out. You're not returning something. So we use procedure. You take a list, you want to do some sort of operation to the list. You are not producing an output. But for function, you produce an output, which means you can save that output and reuse that output for something else. Okay, that's the difference between procedure and function. The second part of this lecture would be file handling, because we might want to read a file, for example, an Excel file, and do some sort of operation on that file. Okay, that is file handling. Of course, first we need to read, and then we do some sort of operation, then we want to write it back. Okay, and then the last one is handling file error. In Python, we have a nice try and catch function, try and catch command, such a way that if the file is missing, it will report to you the file is missing. Okay, that's the purpose of this. We want to learn how to install other libraries. Just now you saw 2 libraries that came with your package. One is math, import math. That is actually came with your Python package. So there are other libraries that you can use freely. In fact, Python itself is free. Anybody and everybody is developing a library. So we want to know how to install a package and use. For example, this is a NumPy array package. Very, very important for matrix operation. Okay, even though we saw just now a list is a simplified version of Python. Rather, NumPy array is a nice version where we can write matrices. And finally, we also learn a little bit on pandas. This data frame is just like a table in Excel file that you saw. You can just like a table in Excel file that you saw. Okay, but the package is called pandas, so it has got its own name called data frame, rather than calling it as a table. Okay. Yes, let's go through the first one. Okay. Now look at lambda function first. I think I'm trying to show the simplest version first, which is a lambda function. Okay. You see the word now lambda. Huh? The name of the function is square. And then this is the command lambda x. So basically the input is x. The output will be x power of 2. The name of the function, square is the name of the function. And then lambda x, basically the input. X is the input. The output would be x power of 2. So you write square for our power will be x is your input, The output will be x power of 2. Huh? That's the simplest lambda function. Okay? Now I can keep on using square. I want power of 100. That's our output. Power of maybe, that's our output. You see, that is the purpose of writing subroutine. We can reuse as many times as we want. Okay, this is simplest lambda command in Python to write a function. Okay, next example. Okay, area of circle is lambda. See, for example, now I want to write a function called area of circle. Okay, the input for the area of circle is radius. So I write lambda radius. This is the input. The output will be pi times r square, right? So area 2, for example, area underscore circle 2 means radius is 2. So I get here, the output would be, the area of the circle will be 12 point something 5664, right? So I can always reuse area circle. It will appear to me once I have run it. So this time around, let's say the radius is 7 or maybe 7.5. So their area of the circle would be 176.7 plus 715. Okay. So again, that is the purpose of writing a subroutine, writing a function so that we can keep on reusing as many times as we like. Okay, example again. Now double, so-called double. Yeah, so-called a function double. Right? So lambda x is the value for each item. The output will be x power of 2. Okay, for what? For nums. Okay, so this map again, I said it will map 1 double become, right, where's 1? Something wrong. 2, 4. Where did I do times? Oh, times 2. I thought power of 2. Okay. So if we want to do power of 2, is also pretty much easy, right? Just put another multiplication. You get 1, 4, 9, 16. Okay. So very easy to play with lambda. Of course, this is a very simplified one-line input and output. So we use lambda command to create this function. Okay. Did you try tutorial? Yeah, good. So if you try, very good. So lambda, what is the input? The input is n, and the output would be this. This is the output. Okay, true or false, right? And the logical operator is this. Right? 2 times equation is means yes or no, right? And mode 2 equal to 0 means, are you asking a question? Is n mod 2 equals to 0? If yes, output is true. No, output is false. Okay, so again, you can try. So this is your answer, right? So again, giving maximum value. And then next is procedure. So first you saw just now, you have output. Yeah, you have output. For example, output where? So output, for example, how to see a true false. True false is our output. For example, here output is it's a list. Here the output is a area of the circle, right? Now let's see procedure. Procedure has no output. Let's see how do we write procedure. Example. Definition. The command def represents definition. Okay, the definition of the procedure, the name of, okay, I say the name, small, simple English. The name of the procedure is grid. The input is name. Okay. Then the output is print hello name. Whatever input you give, hello name, welcome to Python programming. Okay. And this, the triple quote here, right? I put simple triple quote here, and this is the help statement. You can write anything you like. You develop your own procedure. You write your own how to use this procedure here, and you give to your friend. Your friend will read this and understand, and he knows how to use, and you give to your friend. So let's see. Now we have written this. Now let's see how to use it. You run. Okay. When you run, after you run this, you first put greet the name of your procedure. Put a question mark. Run. When you write a question mark and run, first of all, it says, what is the signature? Greet name. The name of your procedure is greet. The input of your procedure is name. And how to use it? They will read, this is a help statement. This one came from where? Just now, right? Just now, whatever that someone wrote and gave it to you, how to use, right? That will come out. And then, of course, you can start using it. For example, greet James, greet Ali, greet Aisha. Oh, you see? Now you just can call and use. Is this output? Of course, it is output only printed on the screen. Okay, yeah, okay. There's no value in return. Okay. That's why we call it as a procedure. It does something. For example, I'm going to say, okay, create a procedure. I won't say procedure. I will say create a subroutine to print out a multiplication table. First of all, you should understand it is just printing out. It is a procedure. So this is how you write. I'm just going to print out. So I'm going to give number. So then it will give the multiplication table. Right? So the multiplication is this. This, of course, you have learned about writing a multiplication table previously. So use that, put it in there, and just print it out. So this is the definition, the whole definition for this procedure. So print table, it prints table 3 for you nicely. All right? Print table 12. You see now, you don't need to re-code. Just call. Right? All right. So that is the purpose of procedure. Right. We also use procedure to manipulate list, manipulate table. Just manipulate it. That's it. We don't store. We don't return anything. Okay. We also do that. Okay. Now function. As I said. Now let's look at a function. A simple function. This function will add 2 numbers. Right. The name of the definition. The name of this function is add. The input of the function, 2 inputs, A and B. It will calculate result, to return results. Now, this new keyword that you see now is return. Procedure has no return. Procedure has no return. If you see in this, def is the same as same gun, same. For function and procedure, you use def. To differentiate between function and procedure is that procedure has no return. So when you see a return in a def, it's a function. So this time around, when you add these 2 numbers, you can store that number because there is an output. The output is results. Okay, so now, right? So you add 2 plus 3 equals to 5. Okay, you can keep it as value, right? Well, you can keep the output, but previously you can't keep. The procedure you can't keep there because there is no return function. It is just printing out, showing it to you. Okay, that's the difference. So when you want to keep on, like you want to store and do something, then you of course you do a function. Just like want to like do something and just print it out and show it, then use procedure. Okay. You see now here I'm adding, I'm running the add function 3 times here with different input, right? Every single time I do, I can just store it as well. For example, here total, I store it as a total. Okay. Now, when to use? When to use? Yeah. Definition key. Of course, no return function has a return. There's a no return keyword here. Of course, it has a keyword. We differentiate between these two, right? Example with an example. Yeah. So you cannot store this. Rather, there is a return here, so you can store it. Okay. More examples, yeah. Just to differentiate this between these two. Okay. Right. So greet Ali. There's no return, right? Without square, right? Yes, there's a return. Okay, save. All right, tutorial. Did it try? Okay. First question. Your job is to convert this so that you can store the area, right? The first of all, you see, this is a procedure. It will just print out for you. It will not store anything. Right? It will not store. But when you write return site times site, now it will store. Simple. Okay. So now this is a usage. How to use it? So this is function call. Yeah, this is called function call. Once you call a function, the function with input 5, now you want to store it as result. Okay. So when I ask you to, try to show the usage of this function, this is how you show. You call the function with some input, and you can print it out. This is just printing, okay, but this is actually how you store your output of your function. Okay. Another function. So previously we learned about writing an even, using if as even or not. But this time around, we just return and mode 2. This is a logical operator equals to 0 or not. Yes, true, otherwise false. So the output is pretty much, this output is pretty much yes or no. Yeah. See how short it is, how compact it is. No, you can now keep on reusing it. Okay. Okay. Previously, I want to store true or false. This time around, I don't want to. I just want to print it out. I don't want to store, but I just want to print it out on the screen. So now you print out this. In this definition, you don't see a return keyword. Okay. Okay. Now, okay, more interesting. So I want to write this function. Okay. I want to write this function, and of course, this function f2 has input x, y, and z. So write the definition. So this is a function definition. So this time around, I need a square root. Square root is in a math library. So I need to import math library. Okay. All right. Okay, so either you import from math, import square root, and then straight away use square root, and then this the output, right? So of course, return this plus this plus this. Okay, just like the question. Yeah, this is the question given to you. Right. So there's another way of like, you might want to like import like this. Where is that? Okay, you might want to just import math. You can also do that. Okay, I just want to show you the difference. If you just import math in math library, I use a dot SS operator and then I write square root. It's the same, huh? Okay, either you write import math and then math dot square root, or from math import square root and then straight away use square root. Okay, see the difference? So one is you are using a accessing operator, the other one you don't use. Oh, so dot operator to access that function in the math library. Here I know already in the math library, just get that out. Then straight away use it. Okay. And tutorial as factorial, writing a factorial. So previously we saw how we use for loop. Take that for loop and put it in here and then return it as a result. Okay, that's it actually. So now we can print. We can do for any factorial. Okay. A factorial function is a special function which calls itself actually. So a factorial can also be written as a recursive function. Okay. So this is a totally different approach for coding, because we know this factorial, I wrote a factorial underscore recursive a function which calls itself. So inside here it calls itself, but -1, right? So this one is a loop. It runs by itself. It's calling by itself. It's just like a loop. Okay, so this is called recursive function. Okay, because it's calling itself. Okay, we can also, this is another way to code factorial. And this one here. Okay, so given a data, you're supposed to calculate a mean and standard deviation. All right, so this time around, we want to write a function to do that. All right, a function. This function, the input of the function would be data, which is in this form. The output of the function would be mean and standard deviation. So if you have a different set of data, for example, that data represents your class. You're teaching mathematics. Class A, this data. Class B, another data. Class C, another data, right? So you want to write a function, and the output would be mean and standard deviation. So it's just this is it. First given data, which is a list. Find out the length, for example, the number of students in your class. And then you just use a sum function to sum it up and divide by n. N is of course the length of the data. And this is variance, this is a variance, this is standard deviation. And return, this time around we have two output. Mean and standard deviation. See the output, how we do that output? Two. The first one is mean, the second one is standard deviation. The input is just one, data. Now example. So we want to test. This is an example of, for example, marks for a given class. You just put data. automatically it will print out for you. See how I store it. First is M and second is S, because why? The output is 2. M and standard deviation, mean and standard deviation. So I keep M and standard deviation equals to this. So automatically mean is M, standard deviation is S. Okay, so 2 output. 1 input, which is the least, the output is 2. Okay.